is Physics Computation 6. It would be based on only one topic, electricity. As you know, we already divided electricity in two parts, static electricity and dynamic electricity. Static electricity when charged it at rest, and dynamic electricity when charged in motion. When charged in motion, we call it current. When charged it at rest, we call it static electricity. You want to be using Coulomb's law to solve a static electricity problem. You also have to have good understanding of charge by conduction, right? Charge by touching, charge by induction, charge without touching, and also charge by grounding, right? These three things you have to have a good understanding. And you also have a good understanding of electric current. In fact, in this video, I'm going to give you a full understanding of electric current. And before I dive into electric current, I just want to wish you good luck. You're going to be competing against each other as a group, right? And one student would be the student of the month. One student would be the winner, right? The student from the winning group, right, would be the whole group would receive would be able to add 15 points to the test. Okay, so let's get started. I'm going to write down all the equations that you need for tomorrow. It starts from VIR, right? So now current is V over R. Another equation for current is Q over T, delta Q. Another equation for current is, of course, I1 is equal to I2, that is for series. Another equation for current is I1 is plus I2, and that is for parallel. And now let's do it for the voltage. Number 5, voltage is of course IR. Number 6, the voltage can also be V is equal to V1 plus V2, and that is series. Number 7, voltage is V1 is equal to V2, and so on. That's for parallel. Now let's go to the resistance. The resistance is well, you can write V over I, right? And the resistance is also, you can write resistance is R1 plus R2, and that is of course series. 1 over R equivalent resistance is 1 over R1 plus 1 over R2, and so on. This is for parallel. Resistance is also rho L over A. Rho is the resistivity, right? L is the length, and A is the area. What are we talking about? If you consider a wire, right? The wire carries the current, right? Okay, the wire has a length, and the wire has a cross-sectional area. What does cross-sectional area means? The cross-sectional area, if this is a wire, you know, if you take a sharp knife and cut it, and that would be the cross-sectional area. Cross-sectional area is circular, so it has a radius. So cross-sectional area. And this one also has resistivity. When I talk about resistivity, what are you talking about? So resistivity is, let's say, there are superconductor, there are conductor, and there are semiconductor, and there are insulator. What would be the example of superconductor? Superconductor when temperature is at 0 degree Kelvin. Not possible, right? 0 degree temperature is very difficult to accomplish, right? People are trying using Bose-Einstein condensate. Conductor at 20 degrees Celsius, copper, you know, or aluminum, let's say aluminum is 2.82 times 10 raised to negative 8 ohms meter. And semiconductor is about 10 raised to 2 ohms meter. Insulator 10 raised to 15 ohms meter. As you see, insulator like glass or wood, when someone electrocuted, you use the insulator to save the person, to help the person. Okay, so this is what the resistance. So resistance also can be rho over L pi r square, because the cross-sectional area is a circle and circle is pi r square. So these 1, 2, 3, 4, 5 equations is for resistance. I'm going to give a few more equations and then I'm going to move on to solve the problem. The power is VI. The power also can be V square over R. The power also can be I square R, right? Why it is I square R is because V over R, so V square R, and then you have current is so this is also VIR, so I square, V is IR, so I square R, so that's correct. Okay, now let's write the SI unit. SI unit for current is amps, 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 SI unit for voltage is volt, volt, volt. SI unit for resistance is omega, 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 omega. SI unit for power is watts, watts, and watts. Okay, so these are the equations you are responsible for tomorrow. So let's first solve one problem that is with the resistance. Let's say I give you a wire. Wire has a length is 10 meter. Wire has a cross-sectional area, and that is, let's say, diameter is 3 millimeter. And then let's say this is aluminum, right? So now let's first convert it to SI unit. Let's first write radius. Radius is 1.5 millimeter. So then radius must be 1.5 times 10 raised to negative 3 meter. So now area then is this cross-sectional area. So area is pi r square. Right, so area is 3.14 times 1.5 times 10 raised to negative 3 square. So area is 3.14 times 1.5 square times 10 raised to negative 6 square meter. So area is 7 times 10 raised to negative 6 square meter. Now we can solve the problem very easily. Resistance is rho times length over area. So rho is for aluminum, it is 2.82 times 10 raised to negative 8 omega meter. The length is 10 meter, and the area is 7 times 10 raised to negative 6 square meter. Meter goes to square meter once, meter cancel. So your resistance is 4 times 10 raised to negative 2 omega. Okay, so now I'm going to show you, we're done with this one, the resistance. Okay, all right, now I'm going to show you the Ohm's law. Okay, let's consider two circuit. One is series and one is parallel. So let's say this is your series. So this is your positive terminal, your negative terminal. So let's say this is your positive, this is your negative. So let's say you have two bulb, right? You have bulb number 1, which is 3 ohms, bulb number 2, which is bulb number 2, which is 6 ohms, right? And that's it. And now you're going to come over here and you're going to do parallel, right? So the parallel, you have positive, you have negative, you have a parallel, okay. So you have the R1 is 3 ohms, R2 is 6 ohms. Now my question is to you, which one would be brighter for the series? So this is series and this is parallel. Which one would be brighter? Okay, so this one would be twice as bright, and this one would be twice as bright. How do we know? Let's see. So this is the current is same over here across the circuit, and the voltage is same across the circuit. So we're going to keep this in mind to prove that. So the power is, we're going to use this formula, I square over R, I square R. So the power at 6 ohms, the power at 3 ohms is equal to I square 6 and I square 3. I square cancel, 3 goes to 6 twice. So P 6 ohms and P 3 ohms, this is 2 over 1, right? Okay, so this is 6 ohms is twice as bright. Okay, good. Now let's prove this one. P is equal to the voltage, so V square over R. So the P 6 ohms, P 3 ohms is equal to V square 6, V square 3. So P 6 ohms, P 3 ohms is equal to V square over 6 times 3 over V square. 3 goes to 6 twice. So P 6 ohms, P 3 ohms is equal to 1 over 2. So 3 ohms is twice as brighter. Okay, now we're going to prove that. So let's say finally I'm going to give you some value. With the value you feel probably much more confidence. What I actually want you to do is complete this table. So I want you to write bulbs 1, 2, and then I want you to write over here total. You have Ohm's law, V, I, R, and then finally P. Good. You're going to complete this, and then you're going to complete this bulbs. Bulb 1, bulb 2, and then total. What do you want to do? V, I, R, and then of course power. Okay, so what is the easiest thing to do over here? Remember your VIR. VIR is the most important formula, VIR. Okay, so the easy is voltage. Voltage is same across the circuit. So voltage is what is it? 24 volt, 24 volt. So 24 volt. Good. Now we're going to find the equivalence resistance. So what do you know? 1 over R is equal to 1 over R1 plus 1 over R2. You've seen this equation right here. So 1 over R is equal to 1 over 3 plus 1 over 6. So 1 over R is equal to 6. 3 goes to 6 twice. 6 goes to once. So 1 over R is 3 over 6. So then R over 1 is 6 over 3. So R is 2. So what we essentially get is the resistance 1 is 3 ohms, resistance 2 is 6 ohms, 3 plus 6 is 2 ohms. Okay. Oh, no, this is resistance. So let's write resistance. Now I'm going to write current. No, let's write resistance over here, 3 ohms, 6 ohms, and 2 ohms. And this, keep it as current. We don't want to switch current. Now, understand that the voltage is 24 over here, and voltage is also 24 over here. Now, the current is voltage over resistance. So the voltage over resistance, 24 divided by 3, 8. So this is 8. And this is 24 divided by 6 is 4. So the current is 12. Is that true? Let's prove that. Ohm's law tells us that the current is V over R. V is 24, R is 2. Where did the 2 come from? The resistance is 2. So 12. So that's proof. This is 12. Now it's time to do the power. The power is, we're going to use this equation VI. So 24 times 8 is 192. 96. All right, so you're going to add them up. So this is 8 to 88. This is worse, this is worse, this is worse. The power over here is 288 watts. The power over here is 192 watts, and the power over here is 96 watts. So that's right. 192 is twice as big as 96. Now let's come to the series circuit. What is easy for series circuit? Well, the resistance. You have 3 ohms and you have 6 ohms. 3 plus 6 is 9 ohms. What is the next easiest thing to find the current? How can you find the current? Current is, of course, V over R. So V is 24, R is 9, so 24 over 9. So you're going to write 24 over 9, 24 over 9, and 24 over 9. Okay, now voltage. So make sure you write the current over here. The current is, well, let's write the voltage. How much is the voltage over here? Voltage is, I times R. Maybe we need to write the current. So let's write current. So later on we're going to find the voltage, so we're going to use that. So the current is 24 over 9. 24 over 9, and the current is 24 over 9. Now let's find the voltage. Voltage is current times resistance. So 24, 9, the resistance is 3. Okay. So 3 goes to 9 3 times, 3 goes to 24 8 times. So voltage is 8. This voltage would be, voltage is 24 9 times 6, right? Okay. So this is 2, this is 3, 3 goes to 24. 8, so this is 16. 16 plus 8 is 24. Now we're going to do the power. The power is this one. So let's see, this is 8 times 24. 8 times 24 divided by 9, and that is 21. So this must be 42. Okay, so this must be 3 and 6, 63. So the total power is 63 watts, and this one is 21 watts, and this one is 42 watts, and we are right. We said twice, so 42 is as twice than 21.